Bienvenidos, Ushamdid, and welcome University of Maryland Global Campus learners from the CMIT-456 Section 6380 course for the fall 2021 semester. This is the Cisco Networking Academy's CCNP ENARSI version 8 course curriculum. And in this packet tracer tutorial and video, we're going to be taking an in-depth look at packet tracer activity 10.2.1, where we're now going to be troubleshooting multi-area OSPFv3. And again, remember, when we're talking about OSPFv2, we're talking about OSPF with IPv4. When we're talking about OSPFv3, we're talking about OSPF for IPv6. So let's go ahead and dive into the activity. You can see we've got area 0, our backbone area, area 1, and area 2. We have our two area border routers, again, routers that have an interface in area 0 and at least one non-area 0 area. And then we have our autonomous system boundary router, which has at least one interface in the OSPF routing domain and at least one interface that's connected outside of the OSPF routing domain to some other, and it could be EIGRP, BGP, whatever the case may be, but it's an interface that's outside of the OSPF domain. All right, as normal, we've got our addressing table, so let's go ahead and dive into this scenario here. And it says, use the show commands to troubleshoot OSPFv3 area 1. Now, they're going to kind of walk us through this and give us some information. We're going to check on router 2 because R2 is not forming an adjacency with R1. So let's kick open a console on router 2, and let's move from user exec into privilege exec. Now, they recommend that we check the interface IP address configuration, the multi-area OSPF, and this is a typo here. That is definitely a typo right there. It's not multi-area OSPFv2, it's OSPFv3, so just a typo there. And it wants us to use the show running config command. So we can simply say show running config and then kind of scroll down and try to maybe pick things off to see what might be the issue. Now, if we were to scroll back up here, and again, we're on router 2, we can see the loopback interface is loopback 1. We can take a look at the IP to confirm that yes, that is correct. And more importantly, we're interested in this gigabit Ethernet interface right here. And so here is the IPv6 address. And then let's go over to the addressing table and take a look. And so we've got 2001 DB8 area 1 Charlie : 2/64. And so that looks correct. And then we've got a couple things that we should be very wary of right away, right? So is the area correct in the IPv6 OSPF process ID area command? And it says area 1, and we are in area 1, so that looks good. And then we've got the hello interval and the dead interval. Now, this should be pretty quick to check. I'm also going to say show run, and this is another command, router OSPF. And so this is going to be a quick command that we can run because maybe the router IDs are also the same, right? So there could be multiple things going on here. So let's pull router 1 up, and let's also confirm by the show IPv6 OSPF neighbor command. And so yes, there's an adjacency with router ABR1, which I'm going to assume here is going to be router 5 out gig 01. And let's go ahead and do that show run command. And let's come down to the interface here. We've got the loopback interface. And we should be looking at this and immediately notice what the difference is between the gig 00 interface configuration on router 1, right? And gig 00 goes to the 2001 DB8 area 1 Charlie 1, router 2 is 1 Charlie 2. So let's confirm that. Like, do I even have reachability over to the 2001 DB8 area AREA where are we at? 1 Charlie, sorry, these IPv6 addresses get a little cumbersome. And so can I ping router 2? So I've got transit connectivity to router 2. So the connectivity is there. And again, we've been working with OSPF now for a few weeks, and we should easily be able to determine that if this is router 1's gig 00 configuration and this is router 2's gig 00 configuration, we've got some settings here that are a little bit different. So let's scroll back down here, and they actually have another command that we could run, and they recommended the show running config, but you could say show IPv6 OSPF interface gig 00, and this is also going to show me that the dead timer, or the dead interval and the hello interval, are different on router 2 gig 00 than they are on show IPv6, and let's say OSPF interface gig 00 than they are here. And as we know, the hello interval and the dead interval, as well as the MTU, and as well as the area number on the interfaces that are trying to establish an adjacency, those need to match. And so it basically says, is there a mismatch between the configuration? And we know that there is, so what are we going to do? Well, here they have us changing it back to the default. So there's two things that we could do here, right? There's two ways to approach this. We could, on router 2, change the modification back to the default, or on router 1, modify the defaults and change it to what router 2 is set to. And both of those things would work. But what we're going to do here is what they're recommending. We're going to go into interface gigabit Ethernet 00, and we're simply going to say IPv6 OSPF hello interval 10, and remember, on packet tracer or in packet tracer, this does not automatically set the dead interval to 4 times the hello interval. On real Cisco iOS, that is what would happen. I would only need to change the hello interval, and the dead interval is going to modify itself to 4 times the hello interval. And so then we'll set that to 40. In fact, if we were to take a step out here onto a real Cisco router, we're on router 8, and let's say show run int serial 000. Whoops, sorry about that. And we get those extra zeros for free. Do show run int serial 000. And we do have a link local address on here, right? So there is a link local address. If I was to come into interface serial 000 and say IPv6, and let's see if it's going to take this without having any other IPv6 configuration for OSPF set up. Let's just say IPv6 OSPF hello interval, and I'll set it to 20, and then we'll say IPv6 OSPF hello, dead interval, and we'll set this to 100. So now if we were to say do show IPv6 OSPF interface serial 000. And of course it's not enabled. So let's go ahead and we'll try to weasel it in here, even though we don't have anything else set up. IPv6 OSPF 1 area 0. And now let's see if that command is going to yield. There we go. And again, we're just trying to get to this because what I want to show you is this here, right? So these are modified times. Again, on point-to-point network types for OSPF and on broadcast network types for OSPF, the defaults are hello 10, dead 40, wait 40. Now, we changed the dead interval, we changed the hello interval to 20, the dead interval to 100. Now watch what happens if I pull the hello interval back up, and let's change it to 30. So then we're going to rerun the command to show the interface, and you'll notice once it's changed, it doesn't change. When you initially change it, it changes, right? So we initially changed hello to 20, the dead would have automatically changed to 100. However, when you subsequently change it, and I showed you this in another video, if it's already adjusted, this doesn't change because 4 times 30 would be 120. Now you would have to re-enter the dead interval command. So remember that initially, if you modify the hello interval, the dead interval will change to 4 times the hello interval. However, if you manually change the dead interval like I did for this interface here, now we have to manually modify the dead interval. It's not going to get set. And even if I was to set the hello interval, let's set it back to, not 0. Let us set it back to 10. And let's take another look at interface serial 000, and take a look. The dead interval has been set. So let's do this. We're going to say no IPv6 OSPF dead interval 100. So now what does it look like? Well, now it looks like 10 and 40. So what if I change the hello interval? And again, we're back to the defaults now, right? Where we have not hard-coded the dead interval value. So now what if I change this to 30? Now what does it look like? Right, it changed it to 4 times that. So now if I adjust the hello interval, and let's go ahead and change the hello interval to 20. Remember, the dead interval has not been explicitly changed, manually changed. Therefore, it will adjust to 4 times the hello interval. So hopefully that made sense, right? Again, once you manually change the dead interval, that is it. It is set until you either manually change it again or you set it back to the default by removing that IPv6 OSPF dead interval command. So again, just some semantics to remember there. And they had us change the dead interval here. Again, because it had been manually changed, if we don't manually change it back to what we want it to be, it would have stayed at whatever, what was it, 100? Yeah, it would have stayed at 100. And there we go. Adjacency goes from loading to full. All right, so now we're down here to check router configurations in area 2, which is over here, this light blue area, starting with ABR2. Now, again, they kind of walk you right through what the issue may be, what the issue might be. But let's take a look at ABR2 here, and let's say show run pipe into section router OSPF. And you can see there is router 2. If I was to say show IP interface brief, right? We don't see anything because remember, we're using IPv6. I would have to say show IPv6 interface brief or show IPv6 OSPF interface, right? Now, take a look here. Router process 10 inactive. So we kind of walked ourselves into this wanting to see what the interfaces that are configured would look like. And what do we see? And we saw this earlier when we did the show run section. And of course, I've got the answers here. So I was checking to make sure that it was going to give us what we thought we would see. And we certainly do here. But I like the error message, which is router process 10 inactive. Please configure a router ID. So no router ID has been set. So we would come in here and, we're going to say IPv6 router OSPF, and the process ID should be 10. And of course it's 10, it's not 1. All right, and so let's go ahead and set our router ID to 6.6.6.6. So now we have a router ID. So think of it like this. ABR2 didn't have a social security card that uniquely differentiated it from all the other routers in the OSPF routing domain. We just issued it its social security card. So now it can participate as a member in society, in this OSPF society that we have here, because it can be uniquely identified, right? And so there we go. And so that adjacency has now come up. So we're on the ABR, and they're asking us to do a little show IPv6 OSPF database. And I'm going to actually make this a little bit larger so we can see sort of the full swath here of, and there you can see there's quite a bit of information. And so when we look at the OSPF database, OSPFv3 database, we can see that this is our router ID and the process ID is 10. And now we see the type 1 LSAs, right? Those router LSAs. And so what routers for area 0, right? Because remember, this is an ABR. So it has a database, and that database has entries for area 0 and area 2. And you can see right down here, we get into the area 2 router link states. So you could think of it like this when we're talking about the link state database, and specifically on an ABR. And when, and when you see it like this, what we have and what we want to look at here is, where are we at? Is kind of like the line gets drawn right here between area 0, right, and where area 2 starts up. So there's our area 2, and here's where area 0's information ends, and now we've got this information here for area 2. Because this ABR, this area border router has interfaces in multiple areas. Again, by definition, that's what an ABR is. So you get to see some pretty interesting information here, right? Here are the inter-area prefixes, right? Type 3 LSAs that we're receiving. We've got the router link states, which are the type 1s. We've got the inter-area. We've then got the link, right? Remember, the link local LSA. And what that is, right, is it's just kind of the association between any global unicast address prefixes that are on that interface that would be associated with the link local IP, right? That's that type 8. And then we have the type 9, the intra-area prefix. Again, the type 8 and the type 9 are new with OSPF-v3. And to comment, OSPF-v3 was a complete rewrite of OSPF-v2. They literally started from scratch and rewrote everything from the ground up. And so what this intra-area prefix link state is referencing for area 2 anyway, is it's the IPv6 prefixes associated with a stub, a transit network segment, whatever the case may be, or a router, right? And that's what these are referencing. And so this is what our link state database looks like. All right, so now the final check is we're going to check the ASBR, the Autonomous System Boundary Router, or sometimes you'll hear it referred to as the Autonomous System Border Router. Both are legit. And let's get rid of that there. Okay, and so here we are, and now we're worried about a default route being, I'm looking at the ISP address here, 2001 DB8 Charlie 1 : 1. All right, because if I'm down here on router 4, there's probably a good chance that if I was to say ping 2001 : DB8 : Charlie 1 : 1 : that I might not get there, right? And the reason that I'm probably not going to get there, and that this is going to be true probably from all of the routers with the exception of the Autonomous System Boundary Router, which is directly connected to the ISP, is because if I say show IPv6 route, you'll notice that the gateway of last resort is not set, nor am I learning a default route from anybody else, right? So I don't have a longer, more specific match here in my routing table to help me get up here to this IPv6 prefix. And so on the Autonomous System Boundary Router, if we were to go ahead and get into privilege exec and say show run and then pipe it to section router OSPF, you would see the OSPF process ID is 10. There is no default information originate in here, right? So, excuse me. So let's also go ahead and say show IP route. Do I even have, whoa, hold on, take a look at that, right? So I don't even have a gateway of last resort. So there is no default route that has been set. In fact, I don't even have, let's see here, show IPv6, and I said show IP route, I'm sorry, show IPv6 route. There we go. I was like, wait a second, there should be a little bit more information in there than that. So you can see here, we do have a default route configured. Okay, good. So the : 0 has been configured, and it's a static default route. If I was to say show run, pipe it to include route, there it is, IPv6 route : 0, and we need that default information originate statement. So let's get into global config, router OSPF 10. And OSPF 10, I thought it was OSPF 10. Do show run. Hold on one second here. Oh, you know what? I keep using these, no router OSPF 10. I keep using the IPv4. So IPv6, router OSPF 10. There we go. That's going to be a little bit more productive for us. And then default information originate. So now if I was to drop down here to router 4 and say show IPv6 route, right, to get out of that IPv4 mindset, we should see shortly here that we're going to pick up a default route, and there it is, my OE2, right? So it shows up as an OSPF external it's a Type 5 LSA, but it's the, where are we at? The OE2, and there it is right there. I was trying to find it. It's the external Type 2, right? But it'll be a Type 5 LSA, and there it is right there. So now we do have the default route. So if I was to pull back that ping command and try to ping to get out, we should have success, and it might be that the ISP does not have a route to get back to us, but let's confirm. Or maybe we're not supposed to be able to ping that. And can I even get onto this ISP router? The config is locked. So I can't get to the ISP router. Maybe they're trying to have me ping the autonomous system boundary router. And let's go ahead and try to hit the gig interface on that. And we'll do the ping Charlie 1 colon 1 colon 2. Is what it is. So there we go. So we can get all the way to the ASBR. Again, they're not asking us to hit the ISP. But if the ISP had a route to get back to us, that would successfully work. All right, well, that is going to wrap up this tutorial. Again, it was kind of a soft landing into troubleshooting. They walked us through a couple of scenarios and kind of really guided us and gave us the information we would need to solve those things. So very, very good activity, and definitely make sure you make a note of those troubleshooting commands that we used. All right, thanks so much for watching, and as always, I hope to see you in the next video.